Have you ever found yourself sitting at your desk at like 4:45 p.m. on a Friday, just staring blankly at a massive spreadsheet?
Oh, that Friday afternoon spreadsheet dread. I know it well.
Right. Like the CFO needs the quarterly consolidation report before 5. You've just exported, I don't know, 50,000 rows of fresh data from your company's CRM system.
And you think you're totally in the clear.
Exactly. You confidently write your trusty VLOOKUP formula to pull in the revenue figures. You hit enter, and instead of a number, you get hit with that dreaded, capitalized, agonizing error code.
Ah, the hashtag NA.
Yes. Hashtag NA. It's just staring at you.
It is a uniquely modern kind of panic, isn't it? You know the data is there. You can literally see it with your own eyes on the other tab, but the software, it just refuses to acknowledge it.
Totally. So you start sweating, you delete the
Yeah.
formula, you retype it. Still hashtag NA.
Yeah.
You end up manually copying and pasting individual cells for 2 hours. You miss your train home, and your weekend starts off with a massive headache. And honestly, the worst part.
Finding out what actually caused it.
Yeah. You find out on Monday that the entire disaster was caused by a single, invisible space character hidden at the end of a client's name. One invisible space ruined your entire Friday night.
I mean, that invisible space is what we call a structural data failure, and it happens, honestly, thousands of times a day in corporate offices around the world.
Just because of a space.
Yeah, simply because most of us were never taught the underlying architecture of the tools we use. We just kind of wing it.
Which is exactly why we are here today. Welcome to the special edition of The Deep Dive, brought to you in collaboration with the CortexLab podcast series.
We're really excited to get into this one.
We are so incredibly excited to have you with us today because we are treating this session like a friendly, highly practical, over-the-shoulder coaching clinic.
Just imagine we are sitting right there next to you at your desk, coffees in hand, looking at your monitor.
Exactly. We are going to be your knowledgeable colleagues today, and our target isn't the total beginner.
Right, we know you already use Excel. You know what a spreadsheet is.
You know how to sum a column?
Yeah, but there is this massive chasm between, just using Excel and actually commanding it.
So the goal here is to take you from an everyday user to the undisputed spreadsheet guru of your office. The person everyone goes to when their data is a complete corrupted mess.
The office hero, basically.
To get us there, we've synthesized an incredible stack of advanced resources. We are pulling insights from comprehensive manuals like the Excel 2022 10 Minutes a Day Crash Course.
Which is fantastic, by the way.
It really is. Plus, deep dive architectural guides on Excel efficiency, avoiding critical errors, and even some highly complex financial modeling roadmaps.
And my role here is to ensure we don't just memorize what buttons to click. That doesn't really help in the long run.
Right, you're going to keep us grounded.
I'm going to try. The true value comes from understanding the why and the how. Like, why do certain legacy exports cause formulas to break? How does the calculation engine actually process an array? When you understand the underlying logic, the software stops being this unpredictable obstacle and starts becoming a direct extension of your own analytical thinking.
Okay, let's unpack this. I want to start before the data even arrives. I want to talk about the physical environment of the spreadsheet itself, like the exact moment you open a blank workbook.
The blank canvas.
Exactly. Every single one of these advanced manuals starts with a foundational layout trick that seems completely counterintuitive. It's called the B2 rule.
It is counterintuitive at first, yeah. But it fundamentally changes how users interact with your data.
Okay, so when I open a new sheet, my mouse naturally gravitates to the very top left corner, cell A1.
Because that's how we read, right? Top left.
Right. It's the beginning of the page, so that's where you start typing your headers. But the manuals say absolutely not. They say you always begin your data entry on row 2 of column B.
Yes, leaving row 1 and column A completely blank.
Now, I have to push back on this immediately, because if I do that, isn't it going to mess up my printing margins?
That's usually the first question people ask.
I just feel like my manager would look at that and ask why I'm wasting valuable screen space and, paper.
It's a very common concern, but it misunderstands how cognitive load works in digital environments.
Cognitive load.
Yeah, think about the psychology of eye tracking. Densely packed data bores and overwhelms the human brain before the analytical reading even begins.
Oh, interesting.
If you push all your text and numbers flush against the absolute top and left borders of your screen, it creates this claustrophobic visual experience.
Oh, like reading a novel that has zero margins, where the ink literally bleeds right off the edge of the paperback.
Yes, it would be exhausting to read.
Yeah, it would be awful.
Precisely. By intentionally starting in cell B2, you are creating what graphic designers call white space or breathing room.
So it's not just a formatting quirk.
Not at all. This isn't just an aesthetic choice. It optimizes cognitive processing. It frames the data.
Okay, I can see that.
When your manager looks at a spreadsheet starting in B2, they aren't looking at a cramped storage locker of numbers. They are looking at a framed, intentional dashboard.
And what about the printing issue?
Oh, as for printing, Excel's print settings allow you to define the print area independently of the physical grid, so you literally never waste paper.
Okay, that framing concept makes a lot of sense. The reason we format with white space isn't just to make it look pretty, it's to reduce the friction of reading the data.
Exactly. Frictionless reading is the goal.
And speaking of that reading friction, there's a massive warning in the sources about how we align our data within those cells.
Ah, yes, the center alignment trap.
Yes, I am completely guilty of this. You get a messy data set, you highlight the entire grid, and you just hit the center align button because it makes everything look symmetrical and neat.
You feel like you're cleaning up.
It really does. But the efficiency manuals treat center alignment for raw data like it's a cardinal sin. They say texts must be aligned to the left and numbers must be aligned to the right. Always.
Always. Let's break down the mechanical reason behind this rule, specifically for the numbers.
Okay.
If you center align a column of financial figures, say you have 10, then 1,500, then 45,000, what happens to the visual structure?
Well, the numbers kind of bulge out from the middle.
Exactly. The decimal places don't line up, the final digits don't line up.
Right, it looks like a zigzag.
So when a financial analyst or an executive scans down that column, their eye has to physically zigzag back and forth just to figure out the magnitude of each number.
It forces the brain to do extra processing.
Exactly, just to read the value. But if those numbers are right aligned,
Then the ones column lines up perfectly, the tens line up, the hundreds line up.
and the brain instantly grasps the scale of the data without even reading the individual digits. It's all about creating that frictionless vertical scan.
That makes so much sense. And what about text?
Text remains left aligned because that is naturally how our eyes are trained to track in Western languages.
Right, we read left to right.
Exactly. When you center text, you create a ragged left edge, which constantly resets the eye's starting point for every single row. It's tiring.
Okay, so we're keeping text left and numbers right. But let's talk about the space between those columns.
A column width.
Yeah. If we're trying to create this perfect, frictionless reading experience, isn't the easiest solution to just use the autofit feature?
Oh boy.
You know what I mean? Right, you highlight the sheet, double-click the boundary between two columns, and Excel automatically snaps the column width to perfectly fit the longest word in that column. It takes literally 1 second.
It does take 1 second, and it is entirely automated. But the architectural guides specifically warn against relying on autofit for your final presentation.
Wait, really? Why? It seems perfectly efficient.
Because autofit prioritizes mathematical efficiency over human readability.
How so?
It hugs the text far too tightly. It eliminates the very white space we just established with the B2 rule.
Oh, so it ruins the breathing room.
Exactly. When you rely solely on autofit, your columns end up with wildly inconsistent widths, like one column is 3 inches wide because of a long header, and the next column is ½ an inch wide because it just contains a 2-digit code.
Yeah, it looks totally chaotic.
It looks generated by a machine, not curated by an analyst.
So what's the alternative?
Manually adjusting your core column widths. Giving them a consistent, standardized width shows intention. It tells the viewer that you are controlling the data rather than letting the software dictate the design.
So we have our canvas prepared. We are starting in B2. We are right aligning our numbers, and we are showing restraint by manually controlling our column widths.
A beautiful foundation.
But a beautiful canvas is useless if we don't know how to actually build the structure without slowing to a crawl. Moving around the grid and entering data is where I see people waste massive amounts of time.
Usually because they treat Excel like Microsoft Word.
Yes.
They try to format the data at the exact same time they are entering the data.
Let's talk about the physical friction of data entry, adding rows, for example.
Okay.
For the longest time, I thought I was being a power user by using the keyboard shortcut to insert a row. Ctrl, Shift, plus. I do it constantly.
It feels fast when you're doing one row.
Right. But the modeling roadmaps actually suggest this is a bottleneck if you are doing bulk structural changes.
It's a huge bottleneck because of the repetition. If you are building out a financial model and realize you need 12 new rows for a new product category.
Pressing Ctrl Shift plus 12 consecutive times is physically inefficient.
Exactly. Your hands get cramped, you lose count of how many you inserted.
So what's the optimized method?
You leverage the visual interface for bulk actions. You take your mouse, click and drag over the row numbers on the far left to highlight exactly 12 existing rows.
Okay, highlighting the numbers themselves.
Right. Then you right-click anywhere in that highlighted area and hit Insert. Boom.
And Excel instantly injects 12 perfectly clean, blank rows and pushes your existing data down.
It's a small mechanical shift, but it highlights a broader philosophy. Match the tool to the scale of the task.
I love that. But there's an even bigger friction point that slows users down, and it goes back to your point about treating Excel like Word. It is the absolute prohibition against manually typing formatting symbols.
Yes. Never manually type a $ or a comma.
Never.
Never. Enter raw numbers only and format later.
This concept completely changed how I build spreadsheets.
Walk me through a standard beginner's workflow for entering a price list, just to illustrate.
Okay, so a beginner looks at an invoice. The first item is $1,500. They click on cell C2. They hold the shift key to type the $sign.
Right.
Then they type the 1. Then they search for the comma key.
Yes.
Then 500. Then the period. Then 00. Finally, they hit enter.
So they've pressed 9 keys, engaged both hands in awkward stretching motions, just to enter a single standard value.
It's exhausting.
And in doing so, they have misunderstood how Excel processes information.
What do you mean?
Excel operates on a 2-layer system. There is the data layer, the raw, unformatted value stored in the software's memory, and there is the presentation layer.
The visual mask.
Exactly, the visual mask placed over that raw data so humans can understand it. When you manually type $ and commas, you are forcibly trying to combine the data layer and the presentation layer through sheer typing effort.
It completely breaks your flow. You are acting as the formatting engine instead of letting the software do the heavy lifting.
So what is the efficient way?
The guru way is to stay entirely on the 10-key number pad if you have one. You just type 1500, hit enter, 2400, hit enter, 350, hit enter. Your hand never leaves the numbers.
And then
When the entire column is populated, you highlight it, click the currency format button on the ribbon once, and Excel instantly drops the $signs, commas, and decimals perfectly into the presentation layer for all of them simultaneously.
you decouple the data entry phase from the data formatting phase. It speeds up raw input exponentially.
But decoupling those phases sometimes leads to a moment of sheer panic for intermediate users.
Oh, I know where this is going.
You've just rapidly typed in all these large numbers, you hit that currency button, and suddenly your entire column of meticulously entered data vanishes, replaced by a wall of pound signs.
Hashtags. Just hashtag, tag all the way down.
Yes, the hashtag error. It elicits a very visceral reaction.
It really does. It looks like a severe system failure.
It is terrifying. I remember the first time it happened to me, I genuinely thought I had corrupted the file. I thought I broke the formulas, that the data was permanently gone, and I was going to have to start all over.
But what is the software actually trying to communicate when it does that?
Well, seeing those pound signs is basically like thinking your car engine is completely blown and on fire, when in reality you just have the sun visor pulled down and you can't see the road.
That's a great analogy.
It's purely a display limitation. It just means the number in the cell is physically wider than the column width you've set.
And you know, Excel is actually protecting you here.
Protecting me by giving me a heart attack.
Think about it. Imagine if it didn't use the pound signs. Imagine if your column was too narrow and you had the number 1,500,000.
Okay.
If Excel just visually cut off the last 3 digits because they didn't fit, it would display as 1,500.
Oh.
You might accidentally approve a budget that is off by a factor of 1,000.
Oh, wow. I never thought about it like that. So the pound signs are Excel's way of saying, I refuse to show you partial misleading data. Make the column wider, or I'm hiding the whole thing.
Exactly. You just hover your mouse between the column headers, click, drag it a 1/4 inch to the right, and the numbers instantly reappear.
It's a display safety mechanism, not a computational error.
Understanding that distinction saves hours of unnecessary troubleshooting.
Totally. But while the pound signs are harmless, the manuals outline several hidden dangers during the navigation phase that are absolutely critical.
Chief among them is the integrity check when inheriting workbooks.
Oh, this is such a crucial corporate survival skill.
Yeah.
We rarely build spreadsheets entirely from scratch anymore. Usually, we're taking over a template from a coworker or downloading a massive report from a different department.
And when you use someone else's spreadsheet, you are inheriting their logic, their formatting, and most importantly, their unseen mistakes.
Let's set the scene. You get an email from the regional director. Here are the Q3 sales figures by territory. Please run the variance analysis for the board meeting tomorrow.
A standard request.
You open the workbook. It looks beautifully formatted. They use the B2 rule. The numbers are right aligned. You start writing your SUM formulas. But if you aren't paying close attention to the actual lettered headers at the top of the grid, you might miss a massive landmine.
You're reading across column A, column B, column C.
And the next column is column E.
Column D is hidden.
It is completely invisible. The boundary line between C and E might be slightly thicker, but that's literally the only visual clue.
Now, why would someone hide a column in the first place?
Yeah, why did people do that?
Usually it's not malicious. It's because they had a messy calculation column, maybe an intermediate step in a complex formula, and they thought it looked ugly. So instead of moving it to a dedicated background data tab, they just right-clicked and hit hide to clean up their presentation layer.
But the danger is that you, the new user, don't know it's there.
Right.
If you write a formula that highlights a range from C to E, it includes that hidden D column. If column D contains obsolete baseline numbers or deprecated data, your SUM formula is now contaminated.
And you will confidently walk into the board meeting and present a variance analysis that is fundamentally wrong, all because of invisible data.
Missing a hidden row or column means you are basing critical business analysis on an incomplete or misunderstood data set.
So what's the fix? The very first thing a guru does when opening an inherited workbook is click the Select All triangle in the top left corner.
Between the A and the 1.
Exactly. You right-click any column header and select Unhide. Force the spreadsheet to reveal all its secrets before you trust a single number.
Trust but verify. I like that. And speaking of verifying, we have to touch on the most insidious data entry trap of all. The transposing error.
Human error.
Yeah. You are typing fast. You mean to enter a product code of 563, but your fingers slip and you type 536.
This is where we reach the limits of what the software can do for you. Excel is a brilliant computational engine, but it is not psychic.
Right. It won't throw up a red squiggly line under 536 like a spell checker would in Word. To Excel, 536 is a perfectly valid integer. It has no idea that it represents the wrong product.
Which highlights why creating that frictionless reading environment, the white space, the correct alignment is so vital.
Oh, because it makes it easier to spot.
Yes. When the data is clean and visually structured, a human proofreader can scan a column and spot an anomaly much faster. If the data is crammed together in a chaotic mess, a transposed number becomes completely camouflaged.
Okay, so we've established our clean canvas. We've navigated the grid safely. We know how to bypass the formatting friction. We aren't panicking at display errors. And we've thoroughly checked for hidden traps and human errors.
The raw data is secure.
But static numbers don't give us insights. How do we actually wake up the calculation engine and make the spreadsheet start working for us?
This is the transition from using Excel as a digital filing cabinet to commanding it as a computational powerhouse. And it all begins with one specific, profound keystroke.
The equal sign.
Yes, the equal sign. Every single formula, whether it is a simple addition or a massively complex nested array, must begin with an equal sign.
It is the trigger.
Exactly. When you type an equal sign, you are fundamentally changing the state of that cell. You are telling Excel, stop merely storing the characters I type. Wake up, look at the references I'm about to give you, and evaluate them.
It changes the cell from a passive container into an active processor. But once that processor is awake, we have to understand the strict rules it follows. We have to talk about the order of operations.
This is a concept everyone vaguely remembers from primary school math, but its application in financial modeling is literally a matter of corporate life and death.
Parentheses, exponents, multiplication, division, addition, subtraction. I know the acronym, but why is it such a critical focus in advanced Excel manuals?
Because of the devastating business impact of silent errors.
Give me an example.
Let's imagine you are building a commission calculator for your sales team. A salesperson earns a $500 base salary plus a 10% bonus on their total sales. So you write your formula, you wake up the calculator with the equal sign, you type 500 plus sales, 0.10.
Okay, that seems perfectly logical. Base plus sales times the bonus.
But if the salesperson sold $10,000 worth of product, how does Excel calculate that formula without parentheses?
I guess it follows the math hierarchy.
Right. According to the strict mathematical hierarchy, multiplication happens before addition. So Excel takes the $10,000 in sales, multiplies it by 0.10 to get a $1,000 bonus, and then adds the $500 base. The total commission is $1,500.
Which is correct.
It is correct. But what if the compensation plan changes? What if HR says the new policy is that the 10% bonus applies to the combined total of their base salary and their sales?
Oh, okay.
You go back to your formula. If you leave it as 500 plus sales 0.10, Excel will still do the multiplication first. It will only apply the 10% to the sales. It completely ignores your new business logic.
And the software won't warn you. It won't throw up an error code saying, hey, your logic doesn't match the HR policy. It will just confidently output $1,500 and you will end up underpaying your employee.
Exactly. Parentheses are how you control the narrative of the math.
So how do we fix it?
By wrapping the first part of the formula in parentheses, so open parenthesis, 500 plus sales, close parenthesis, times 0.10, you are overriding the default hierarchy.
You are forcing Excel to add the base and the sales together first, getting $10,500, and then applying the 10% multiplier to the whole sum, resulting in the $1,050.
Parentheses are literally the steering wheel for your logic.
You cannot trust a complex formula if you aren't explicitly steering the order of operations. Okay, so we are controlling the math. Now we have to explore the feature that I genuinely believe is the biggest hurdle for intermediate users, but also the single most powerful structural concept in the entire software.
Relative versus absolute references.
Yes, relative versus absolute references.
This concept is the key to scalability.
Let's break this down. By default, Excel uses relative references. If I am in cell C1 and I write a formula that says A1 plus B1, I'm telling Excel to add the two cells immediately to the left.
Right.
If I take my mouse, click the little square at the bottom right corner of C1, the fill handle, and drag that formula down to row 2, Excel automatically changes the formula. It doesn't copy A1 plus B1, it changes it to A2 plus B2. It relates the formula to its new physical position on the grid.
And honestly, 90% of the time, that dynamic adjustment is exactly what we want. Yeah. If you are calculating the profit margin for 1,000 individual products row by row, you want the formula to slide down and look at the new revenue and cost for each specific row.
Okay, sure. But what happens when you have a variable that shouldn't slide down? This is where people hit a massive wall. Let's look at the sales tax scenario from the manuals.
It's the perfect illustration of when relative references fail catastrophically.
So imagine you have a massive inventory list, 500 different items. Column A is the item name, column B is the price. You need to calculate the tax for every single item in column C.
But they all share one universal sales tax rate.
Right. Let's say it's 8.5%. Instead of typing 8.5% into every single formula, a smart user types that tax rate once, up at the very top of the dashboard, let's say in cell E1.
A centralized variable. It's good practice.
So you go to your first item in row 5, you type B5E1, price times tax rate, you hit enter, it works perfectly, the tax calculates, you feel great.
You're feeling like a guru.
Exactly. You grab the fill handle and you confidently drag that formula down all 500 rows. But suddenly, row 6 says 0 tax. Row 7 says hashtag value. Row 8 says 0. The entire sheet breaks instantly.
Why did it break? Let's walk through the relative logic.
Well, because Excel dynamically adjusted both cell references. When the formula moved down to row 6, it changed D5E1 to B6E2.
And B6 is correct. That's the price of the next item.
But E2 is the blank cell directly underneath your tax rate. It multiplied the price by nothing. And as it dragged further down, it started multiplying by whatever random text or data happened to be in column E.
The relative reference allowed the focal point to slide away from the critical variable. This is where the absolute reference becomes mandatory.
So how do we fix it? We use the push pin.
Explain the push pin.
When you are writing that first formula, B5E1, you click your cursor on the E1 part of the text, and then you press a magical key on your keyboard, F4.
Or for Mac users, that's usually a command plus T or FN plus F4.
Right. When you press F4, Excel instantly wraps that cell reference in dollar signs. It changes E1 to E1 dollar. Now, these dollar signs have absolutely nothing to do with currency.
In the language of Excel formulas, a dollar sign is a physical push pin.
Exactly. The dollar sign in front of the E pins the column in place. The dollar sign in front of the 1 pins the row in place. You have literally tacked that reference to the corkboard.
So now what happens when you drag the formula down?
The magic of scalability happens. The first part of the formula, B5, has no push pins. It is relative. So as you drag down, it slides to B6, B7, B8, correctly looking at each new price.
And the second part?
The second part, E1 dollar, is locked. Every single one of those 500 rows is mathematically tethered back to that single cell at the top of the sheet. You drag the fill handle once, and 500 complex calculations processed flawlessly in milliseconds.
What is profound about this is that absolute references are what allow Excel to scale human logic.
Yeah, that's a great way to put it.
If you had to manually type the tax rate into 500 separate formulas, you aren't really using a computer, you are just using an infinitely scrolling typewriter.
That sounds like a nightmare.
By mastering the F4 key, you build dynamic centralized models. If the government changes the tax rate to 9% next year, you don't rewrite 500 formulas. You change cell E1 to 9%, and the entire workbook recalculates instantly.
That is the definition of being a guru. Centralizing your variables and using absolute references to distribute the math. It's incredibly satisfying when it finally clicks.
It really is.
But manual locking and basic math are just the foundation. What happens when we need the spreadsheet to actually do the thinking for us?
That's when we step into the realm of logical functions and automated data manipulation.
Which brings us to the smart assistants. And I want to start with a tool that still feels like literal magic to me, even though it's introduced over a decade ago, FlashFill.
Oh, FlashFill, activated by Crishrel plus E. It is essentially Excel's built-in machine learning engine applied to everyday text processing.
Let's talk about a real nightmare scenario. Your marketing department sends you a list of 10,000 customer leads. The problem: the data is incredibly messy.
As always.
They gave you one column that has the customer's full name, their company, and their phone number, all crammed into a single cell, like John Smith-Acme Corp-555-0100.
And of course, your CRM system requires the first name, last name, and phone number to all be in separate, dedicated columns.
Right. Historically, extracting that data was a monumental task. You had to use the text-to-columns wizard, which would break if the delimiters were inconsistent.
Or, if you were a power user, you wrote monstrously complex formulas nesting left, right, mid, find, and lend functions just to isolate the word John.
Just writing that out makes my head spin. It was such a fragile and frustrating process.
But enter FlashFill.
Today, you don't write a single formula. You create a blank column next to the messy data and title it first name. You look at the first row, John Smith, Acme Corp. You simply type John in your blank cell and hit Enter.
You are providing the system with a training example.
Exactly. Then you go to the second row. Let's say it's Sarah Jones Tech Innovations. You start typing SAR. Before you even finish her name, FlashFill's pattern recognition engine wakes up.
It's watching you.
It scans your training example. It scans the massive column of messy data. It deduces the logic, the user wants the first word before the space, and it instantly projects a light gray preview of all 10,000 extracted first names down the entire column.
And you just hit Enter to accept it.
It reverse engineers the extraction logic without you ever having to write a single line of code. It is an incredible time saver for data cleanup.
It is, but there are times when we need to establish the logic ourselves explicitly. And that is where the if function becomes indispensable.
The if function. This is where spreadsheets become decision-making engines. I always think of the if function as a bouncer at an exclusive nightclub.
I like that analogy.
It stands at the door of your cell, it checks an ID, and based on what it sees, it routes the data differently.
The syntax is a three-part logical argument. You write if, open parenthesis, logical BCDist, comma, value if true, comma, value false.
Let's apply this to a corporate budget variance report. You manage 20 different department budgets. Column A is the projected budget, column B is the actual spend, column C is the variance actual minus projected.
Some numbers are positive, some are negative.
Exactly. Instead of manually reading every single line to see who overspent, you deploy the bouncer.
You're right. IF C2 or A0, over budget, under budget.
The bouncer looks at the variance in C2. Is it greater than 0? If that logical test is true, the bouncer outputs the text over budget. If it is false, it outputs under budget.
And then you drag that down with your absolute references if needed.
And suddenly, a column of confusing numbers is translated into plain English business insights.
It completely automates the interpretation of the data, and you can exponentially increase the impact of this automated interpretation by layering it with another core tool, conditional formatting.
Yes. Conditional formatting visually alters a cell's appearance. Its background color, its font weight, its borders based strictly on the value inside it.
If the if function gives you the words, conditional formatting gives you the visual hierarchy.
Going back to our budget report, reading over budget 50 times is still reading text.
It takes time.
But if you highlight that entire variance column, go to conditional formatting and set a rule. Format cells that are greater than 0 with a light red fill and dark red text. Instantly, without writing a formula, Every single department that blew their budget glows like a warning light on the dashboard.
And this is where we see a fundamental shift in the management conversation. Let's look at a positive example. Finding the top 10% of salespeople.
Oh, this is a great one. You highlight the quarterly sales column, click conditional formatting, choose top-bottom rules, select top 10%, and format them with a green fill.
3 clicks.
3 clicks. No formulas, no sorting, no manual counting.
And what happens when you put that dashboard up on the screen during a regional meeting? If you just had raw, unformatted numbers, the executives would spend the first 5 minutes squinting, trying to mentally rank the values, asking, wait, did Jim beat Pam this quarter?
The cognitive load is entirely spent on processing the data instead of discussing it.
Precisely. But with conditional formatting, the spreadsheet communicates the insight instantly. The top performers are already highlighted in green. The conversation immediately bypasses the what are we looking at phase and jumps straight to the high-value why phase.
Why is Pam's territory glowing green? What strategy did she use that we can scale?
You use the software to remove the friction of discovery.
Now, quick tip for anyone eager to start building these automated dashboards. The sources strongly advise against relying solely on the little insert function search box when you're trying to find the right tool.
Oh, absolutely. The search box is highly problematic because you have to know what you are looking for in order to find it.
Yeah.
If you don't know the exact name of a financial depreciation formula, typing make numbers smaller over time isn't going to help you at all.
Right, it's not Google. Instead, the gurus navigate to the Formulas tab on the ribbon and use the function library.
The function library categorizes the hundreds of available formulas by discipline: logical, financial, text, date and time, lookup, and reference.
It's like wandering through a library instead of just asking a librarian for one book.
Yes, browsing these categories exposes you to the sheer capability of the software. You might click on the text category just looking for a way to capitalize letters and stumble upon functions that extract substrings or convert data types.
It encourages exploratory learning rather than just transactional searching.
Exactly.
Okay, so we have smart assistants translating and highlighting our data. But what happens when you aren't just summarizing a single table? What happens when you have thousands of rows of data in one workbook and you need to find one specific needle in a massive corporate haystack located in a completely different file?
This is the ultimate test of an analyst, combining disparate data sets. And it brings us to the most famous and infamous tool in the corporate world.
The lookup heavyweights.
Blah.
Anyone who has worked in an office for more than a week has heard the term VLOOKUP.
Oh, yeah. People listed on their resumes, they put proficient in VLOOKUP right next to their university degree.
Because for decades, it was basically the only bridge between isolated islands of data. VLOOKUP stands for vertical lookup.
Right. It tells Excel to scan down the first column of a large table until it finds a specific search term, and then return the corresponding information located a certain number of columns over to the right.
It sounds incredibly useful. Say I have an invoice with a part number, X99, but I don't know the price. I can write a VLOOKUP that takes X99, runs over to the massive master inventory database, finds X99, counts 3 columns over to the right, grabs the $45 price tag, and pulls it back to my invoice.
It is useful, but as the advanced modeling manuals emphatically point out, VLOOKUP has a devastating fundamental architectural flaw.
The neck brace limitation.
Yeah. Explain the mechanics of the neck brace.
VLOOKUP is programmed to operate exclusively from left to right. The data you are using as your search term, your lookup value, like the part number, must physically reside in the absolute leftmost column of the database you are searching.
Which is fine if the database is perfectly designed for your specific query.
But corporate data is never perfectly designed. Let's say you get an HR export of all 10,000 employees. The system dumped the data so that column A is the employee name, column B is their department, and column C is their unique employee ID number.
So the unique identifier is in the middle of the table.
Right. And you, the department manager, have a list of employee IDs for your team, and you want to pull their names into your personal dashboard.
So you try to use VLOOKUP.
You tell it to look up the ID. But because VLOOKUP can only look left to right and the ID is in column C, it is physically impossible for VLOOKUP to look backward to column A to retrieve the name.
It's like a reader wearing a rigid medical neck brace. They can only turn their head to the right. If the answer is to their left, they break.
Exactly. So what does the average user do when they encounter this?
Well, usually they panic, and then they physically alter the corporate database.
Yep. They highlight the entire employee ID column, cut it, and paste it over into column A, shifting everything else around just to appease the VLOOKUP formula.
Which introduces massive risk. When you cut and paste columns in a raw data dump, you risk misaligning rows, breaking other people's references, and destroying the integrity of the original source file.
You are literally altering the architecture of the data to compensate for the weakness of the tool.
Exactly. It's a terrible practice.
So how do the gurus solve this? They throw away the neck brace and use a nested formula, the absolute heavyweight champion of data extraction: index match.
Ah, index match. It represents a profound leap in Excel fluency because it requires you to understand array logic.
It is actually two completely separate functions that we combine to achieve superior omnidirectional flexibility.
Omnidirectional. It has a full range of motion. It doesn't care if the data is left, right, up, or down.
Let's break down exactly how this beast works, because typing it out for the first time is seriously intimidating. Let's start with the scout, the MAMTCH function.
The sole job of the NTCH function is to find a coordinate. It does not retrieve data, it simply returns a position.
Okay, the syntax is MTCH, open parenthesis, lookup value, comma, lookup array, comma, match type.
Right, so translating that to our HR nightmare, our lookup value is the employee ID of our team member, let's say IT shed 44455.
The lookup array is simply the specific column where all those IDs live in the master database, which is column C.
And the match type is usually a 0, which just tells Excel we want an exact match, not an approximation.
So MTCH takes ID shade 4455, sprints down column C, finds it, and says, "Sir, I have located the target. It is currently sitting in row number 8042.
It just delivers a number, row 8042.
Exactly. That is the scout's entire job. Now the retriever takes over.
The index function. The syntax here is index, open parenthesis, array, comma, row num.
The array is the column containing the answer you actually want. In our case, the employee name in column A, and the row num.
The row num is the coordinate that our scout just found. So instead of typing a hard number, we literally drop the entire MTCH formula right into that slot. We nest them.
We tell index, look exclusively at the name column, column A. Drop down to the specific row number that MATCH just discovered, row 8042. Grab the value in that cell and bring it back.
And it does it in a fraction of a millisecond.
Index goes to A8042, grabs Jennifer Lopez, and populates your dashboard. Because you separated the task of finding the row from the task of retrieving the data, the left-to-right limitation vanishes completely.
You never have to copy-paste or alter the source database again.
Now, a skeptic might ask, with Microsoft introducing newer functions like exceltips in recent years, which also solve the left-to-right problem.
Which are fantastic, by the way.
Why is mastering index match still considered a mandatory rite of passage in these advanced manuals?
It's a great question, and the answer is reality, corporate reality. Yes, XLOOKUP is easier, but you are going to encounter legacy systems, protected files from third-party vendors, or older versions of Excel installed on secure corporate servers where XLOOKUP simply does not exist.
If you only know the newest shortcut, you are paralyzed when the environment downgrades.
Exactly. Index match works universally on every system, backwards compatible for decades. Plus, learning how to nest formulas using the output of one function as the input for another is the gateway to true advanced modeling.
Trains your brain in modular logic.
However, even the most elegantly nested index match formula will catastrophically fail if the underlying data structure it is searching is compromised.
Which leads us to the critical concept of database integrity.
This is where we have to clarify some terminology. We use the words spreadsheet and database interchangeably in the office all the time, but architecturally, they are not the same thing.
Not at all. A spreadsheet is merely the infinite grid of cells. It is a spatial environment. When you type headers across row 1 and populate rows 2 through 100 with information, you mentally consider it a database.
But to the software, it is just a loose collection of populated cells floating in the grid. It doesn't recognize the relationships between the columns.
Until you explicitly tell it to. And the way you tell it is the single most important keyboard shortcut for data management, Ctrl plus T.
Or Command plus T on a Mac. This shortcut invokes the create table command.
When you highlight your block of data and hit Ctrl plus T, Excel wraps that raw data in an official structured framework.
It binds the rows together as unified, indivisible records. It automatically adds filter dropdowns to the headers. It turns a loose pile of numbers into a cohesive, recognizable entity.
But building this entity comes with strict architectural rules. And the most heavily enforced rule in the manuals is the absolute prohibition against gaps.
The no gaps rule. No entirely blank rows or blank columns inside your database, ever.
Explain why users are so tempted to break this rule.
Because of visual grouping. If I have a database tracking sales for the whole year, I want it to be readable. So I have all the January sales rows. And then right before February starts, I insert a completely blank row. I just leave row font 5 empty to create a visual break.
It gives the data breathing room.
Aesthetically, it makes sense. Architecturally, it is a ticking time bomb.
Right. Because we don't just keep data in Excel anymore. We export it. We push it to Tableau for visualization. We upload it to Salesforce. We feed it into AI analysis tools via API.
And how do those external automated systems read data?
They read sequentially, top to bottom. They're programs with a very specific stop condition. When an external database is digesting your Excel file, it reads row 43, it reads row 44, then it hits your beautiful, aesthetically pleasing blank row 45.
And the external system's logic triggers, a completely null record. The dataset must be finished. It stops importing.
It completely drops the connection and completely ignores February through December.
You could literally delete 80% of your company's annual data during a CRM migration simply because you wanted a visual break between months.
It is a terrifying concept. A blank row is a hard stop sign for software.
So how does a guru solve the conflict between architectural integrity and human readability?
We use color instead of physical space. When you hit Ctrl+T to create an official table, Excel automatically applies a design feature called zebra striping.
Alternating row colors.
Yes. Row 2 is light blue, row 3 is white, row 4 is light blue. This solves the aesthetic problem brilliantly. It provides a visual guide rail that helps the reader's eye track a long string of data horizontally across 30 columns without losing their place.
It gives the illusion of separation and readability, but physically the rows are tightly stacked with zero gaps. Perfect structural integrity.
Zebra striping is a perfect example of form-following function. But maintaining integrity isn't just about avoiding gaps. It's about the microscopic hygiene of the data itself.
The manuals heavily emphasize data cleaning protocols before any analysis begins.
And this brings us right back to our nightmare scenario from the very beginning of the show, the invisible space character.
The silent killer of lookup functions.
When you export data from older legacy systems, or even when you just copy-paste text from a web browser, the data often brings invisible baggage with it. You might pull an employee name into your database, and it looks like John Smith.
But internally, the system imported John Smith, followed by 3 accidental spacebar hits.
To a human, John Smith and John Smith space are identical. To a computer processing an index match or an F statement, they're entirely different cryptographic strings.
The formula will return #NA because it cannot find an exact match.
And you will drive yourself insane trying to figure out why the formula is broken, checking your commas and parentheses, when the actual problem is invisible formatting.
To fix this, you must deploy the trim function.
Trim is an automated scrubber.
You run your messy text column through the trim formula, so equals trim, and select the cell, and Excel instantly strips away any leading spaces before the word, any trailing spaces after the word, and reduces any double spaces between words down to a single space.
It perfectly sanitizes the data layer.
And once the text is sanitized, you must ensure the records are unique. Which brings us to a very powerful, dangerous shortcut, Alt+A+M.
The Remove Duplicates command. When you have a database of 50,000 records, you physically cannot scroll through to see if a customer accidentally submitted their form twice.
Highlighting your table and hitting Alt+A+M brings up a dialog box that allows Excel to scan every single row, compare it against every other row, and permanently delete exact duplicates.
The danger, of course, is that the deletion is permanent. You must be absolutely certain you have selected the correct columns to compare.
If you only tell it to look for duplicate first names, it will delete every John in your database except the first one.
Oh, that would be bad. Always run Alt+A+M on the unique identifier column, like the customer ID or the order number.
Exactly. So let's take stock of where we are. We have architected a clean, breathable canvas. We have rapidly entered raw data without falling into formatting traps.
We have built robust, scalable calculations using absolute references and proper order of operations.
We have deployed smart assistants and complex nested lookup functions to merge datasets.
And we have sanitized our database into a structurally flawless table.
The analytical heavy lifting is officially done. The math is perfect.
Which brings us to the most perilous phase of the entire process. The phase where brilliant analysis is routinely ignored because of terrible presentation.
Yes. How do we present this masterpiece to the decision makers? This is the final step. The showcase.
Visual restraint and charting. The core philosophy here is that a spreadsheet is a communication medium, not just a storage box.
The manuals are brutal about this. They explicitly state that if your presentation is clumsy and boring, or conversely, if it looks like a neon explosion from a 1990s clip art gallery,
It instantly destroys the perceived value of your underlying analysis. People will assume your math is sloppy if your formatting is sloppy.
let's start with the fundamental terminology. We often use the words graphs and charts interchangeably, but in the realm of data visualization, they serve distinct communicative purposes.
Right. Graphs are generally simpler and more linear. They map data points over a continuous timeline. You have an x-axis for time, a y-axis for volume. A line graph showing website traffic over 30 days, it shows a trend.
Charts, however, illustrate complex proportions and structural relationships within the data.
Now, the temptation for users who just spent hours crunching numbers is to use the most complicated, visually aggressive chart available in the software to prove how hard they worked.
Oh, the 3D exploding pie chart, the glowing neon surface map.
And the psychological reality is that these complex visuals actually distort the data perception.
They absolutely do.
Let's talk about the 3D pie chart. When you tilt a pie chart into 3D, the slices at the front of the image physically take up more pixels on the screen than the slices at the back, simply because of the fake perspective.
A 15% slice in the front will visually look larger than a 20% slice in the back,
You are literally lying to your executives with formatting.
which is why the overwhelming advice is decluttering and restraint. What chart types do the advanced modeling roadmaps actually recommend for corporate environments?
They champion clarity over flash, standard 2D bar charts for comparative volumes, symbol line graphs for trends. But the absolute favorite for executive board meetings, the visual that explains the why better than anything else, is the waterfall chart.
Explain the communicative power of the waterfall.
A waterfall chart visualizes the bridge between 2 points in time by breaking down the positive and negative impacts along the way. Imagine you are presenting the annual financials. You start on the left with a solid bar representing your Q1 starting balance, $10 million.
And you end on the far right with a solid bar representing your Q4 ending balance, $12 million.
The executives immediately want to know, how did we get from 10 to 12?
The waterfall chart answers it instantly. Between those two pillars, you have floating bricks. A green brick going up for the $5 as in new sales.
A red brick dropping down for the $2 in unexpected tax liabilities. Another red brick dropping for the $1 supply chain disruption.
It visually walks the audience through the specific narrative of the year.
It connects the math to the business reality. Note that in some older versions of Excel, you might need to download a specialized template to generate a true waterfall, but the communication value makes it mandatory.
Regardless of the chart you use, however, there are strict formatting protocols to observe.
Total visual restraint. The manuals dictate a maximum of 3 fonts in an entire presentation, and they must be standard, legible, sans serif fonts like Arial, Calibri, or Sego UI. No curly scripts. No dense, distracting serif fonts.
You also must ruthlessly eliminate redundant ink.
Yes. Do not use the centered overlay option for chart titles. This is a default setting that physically pastes the text of the title right over the data lines. It literally obscures the information.
Keep the title cleanly separated above the plotting area. Remove unnecessary axis lines. Remove busy background gradients.
And a critical operational prerequisite. You must sort your data logically highest to lowest, or chronologically, before you generate the chart. If your underlying table is a chaotic jumble of random dates, your line graph will look like a ball of scribbled yarn.
The chart only reflects the structure of the table.
You cannot put lipstick on a pig. Clean data creates clean charts. But my absolute favorite, ultimate power move, visual trick from this entire deep dive has nothing to do with charts at all.
Oh, I know what this is.
It is a 1-second aesthetic shift that instantly makes you look like a software developer going off the grid.
It is remarkably simple, yet it completely transforms the psychological impact of the workbook.
When you have built your perfect variance analysis, your data is summarized, your conditional formatting is glowing appropriately, and you are ready to send the file to the CEO. You go up to the View tab on the ribbon.
And you simply uncheck the little box labeled grid lines.
Instantly, the millions of light gray borders separating the infinite cells simply vanish.
The background becomes pure, solid, crisp white.
Your beautifully formatted tables and charts are left floating in this pristine negative space. It fundamentally changes how the user interacts with the file. It no longer looks like a chaotic calculator.
It looks like a polished, custom-built web application dashboard. It elevates the authority of everything you just built.
Visual should illuminate the data, not compete with it. By removing the grid, you remove the final layer of software distraction.
Okay, let's take a massive breath. We have covered an incredible landscape today. We have completely reconstructed the philosophy of how to approach this software.
We really have. We have moved from raw input to automated analysis to executive presentation. Let's trace the arc of the guru journey one more time.
We started by prioritizing cognitive readability, setting our clean canvas using the B2 rule to guarantee white space.
And strictly aligning our numbers to the right to allow for frictionless visual scanning.
We optimized our physical interactions with the grid, using mouse-driven bulk insertions, avoiding the trap of manual symbol typing.
And recognizing that the wall of hashtags is a call for space, not a sign of corruption.
We performed vital integrity checks to uncover hidden columns and transpose data, ensuring the foundation was solid before we ever typed an equal sign to wake up the calculation engine.
Once awake, we control the computational narrative with strict parentheses, and we unlock the true scaling power of the software by deploying the F4 pushpin to create absolute references.
We automated the heavy lifting with smart assistants, letting FlashFill's machine learning parse messy text.
And deploying IF functions layered with conditional formatting to make our data scream its own success or failure in bright red and green.
We abandoned the rigid neck brace limitations of VLOOKUP, embracing the omnidirectional nested array power of index match to seamlessly merge complex datasets without ever altering the source code.
We locked down our architecture by invoking Ctrl plus T to build official databases, strictly forbidding empty gap rows that destroy external APIs.
And sanitizing our inputs with the trim formula to eradicate the invisible spaces that break our logic.
And finally, we curated our final presentation with extreme visual restraint, deploying narrative-driven waterfall charts and stripping away the grid lines to deliver a pristine, authoritative dashboard.
You, our listener, are now armed with the exact mental models and technical toolkit to fundamentally change how you process information.
You are going to save countless hours of Friday night frustration, eliminate those career-threatening silent errors, and genuinely stun your colleagues. You aren't just reacting to the software anymore. You are commanding it.
And as we close this session, I want to leave you with a philosophical thought, something that connects everything we've just discussed to the rapidly shifting landscape of the modern workplace.
I love these moments. Lay it on us.
When you dedicate the time to master Excel to this architectural degree, you aren't just memorizing syntax for a single piece of software. You are fundamentally training your brain to think in structured, scalable, logical frameworks.
You are learning how to organize chaos into tables?
Exactly. How to apply conditional rules to ambiguous situations and how to build relational models between isolated facts.
It's an entire paradigm for problem solving.
It is. And as artificial intelligence and automated data pipelines continue to evolve and inevitably take over the actual brute force crunching of the numbers, the value of the human worker shifts.
So what's left for us?
Consider this. In the very near future, the true value of understanding Excel may no longer be about your ability to do the math. The true value will be that the software taught you the precise, logical architecture required to ask the data the right questions.
Knowing how to ask the right question is the ultimate superpower. Thank you so much for joining us on this incredibly deep dive. Until next time, keep your data clean, keep your references absolute, and we will see you on the next deep dive.